Hello everyone, welcome to MES e-learning channel. In the previous video, we saw how to find out the resultant by given the forces, right? So in this video, we're going to see some conditions. So here we have three conditions, that is, if resultant is horizontal, then f of y equal to 0 and f of x equal to r. That means, so given some force system, you'll have some force system. They have given some force system F1, F2, F3. Okay. So now they're saying, according to this first condition, they are saying that the resultant is horizontal. Okay. So the resultant is horizontal. So the given R will be horizontal. Okay. So if resultant is horizontal, they're saying that summation of f of y is equal to 0 and f of x will be equal to r. So horizontal means f of x equal to r. So we know one formula that r equal to root of f of x square plus f of y square, right? So similarly, if you put f of y equal to 0 in this equation, we are left with r equal to f of x square, right? So root of f square, this square and root get cancelled, so r will be equal to f of x, same condition over here. And now we look at the second condition, if resultant is vertical, same thing, if the result is vertical means it is acting on the vertical direction, right? This is r. So on the same equation, if you put f of y resultant is vertical, that means summation of f of y will be equal to r and f of x will be equal to 0. To satisfy this condition, second equation, f of y will be equal to r, that means resultant is vertical. So on the other end, f of x will be equal to 0. Then only we can satisfy this condition that f of x is, f of y is vertical. And there is one more condition, that the last condition, that is if resultant is 0, obviously. So if resultant is 0, that means if r equal to 0, then summation of f of x will be equal to also 0 and f of y will be equal to 0. So these are the three conditions we have to look. So when in your question, in your given question, if they say that resultant is horizontal, then f of x equal to r, f of y will be equal to 0. If resultant is vertical, then f of y will be equal to r and f of x will be equal to 0. And the resultant is 0, then f of x and f of y will be equal to 0. Okay. So based upon this condition, we're going to try to solve one problem. So this thing, yeah. So they have given, determine the magnitude and direction of forces F1 and F2 shown in the figure when the resultant of the given force system is found to be 800 along positive x-axis. Okay. So if you see this problem, and if you try to compare this problem with our previous problem, in the previous problem they have given the forces and we were told to find out the resultant and the direction. So in this problem they have given the resultant, but we have to find out the forces. So that is the difference. Okay. So in this kind of problem, so we have to look at the conditions. So they have given the condition that resultant of the given force system is found to be 800, that is r is equal to 800 and along positive x-axis. So when I say positive x-axis, this is nothing but an horizontal, right? So this is our positive x-axis. So this positive x-axis is nothing but horizontal, right? I hope you understand this sentence. So we have to carefully read the questions before solving any question, any problem. So they have given resultant is to be 800 and it's along the positive x-axis. Now we have to find out the forces of F1 and F2. Okay. So now this is 800. So if you know, if this r is f of x is equal to r, right, and f of y will be equal to 0. But according to our condition, they have said that the resultant is along the positive x-axis, that means x. So summation of x equal to r and the other part, that is summation of fy, will be equal to 0. So we have to apply this condition to our problem. Now how to solve this now? So what we can do is we can frame the equation for f of x. So summation of f of x is equal to r. Here what is the summation of f of x? The summation of f of x is nothing but all the horizontal forces. Now if you want to find all the horizontal forces, we can see now. So this we have what all we have. So we have this F2, this is one horizontal which is acting from left to right. So it is a positive. So F2 will be a positive. Then we have F3 force which is inclined at an angle of 36 degree with x axis. So if you want to draw we have to take the component for this. To the component will be like this. If you see, it is moving outward, so the component will also be outward, and this will be, it is making an angle with this thing, so this will be 290 cos of 36 degree, and this will be 290 sin of 36 degree. Again, so the second F4 is also making an angle with 70 degree with horizontal x axis, so we have to draw the component for this as well. So this will be 370 cos 70, and this is acting downward, so this will be 370 sine of 70 degree. So now we have three things. So on this also we have an horizontal force which is acting from right to left. So this will be negative, so minus 290 cos 36 degree, and we have one more thing also here also, it is also acting from right to left, so minus 370 cos 70 degree. So if you put in the calculator, okay, so this is equal to R, so R is nothing but 800. So this is our equation. Now if you put this in the calculator, we will get F2. So to F2, to find out the F2, what we can do is we can take all these terms to the right hand side. That will be 800 plus 290 cos 36 degree plus 370 cos 70 degree, and we'll find out to be F2 will be equal to 1161.2 Newton, which is a positive. It will be acting from left to right. So this is 1. So among one thing we have found out the F2. Now if you want to find out F1, so F1 is nothing but an vertical direction, so we have to take the another condition, that is Fy will be equal to 0. So now here we have to find out the vertical forces. So we have a vertical force F1 which is acting upward, that is a positive, and we have another forces, the components of 290 and 370 forces, that is 290 sin 36 degree which is acting upward, again it is a positive, 370 sin 70 which is acting downward, so it is negative. So we can frame the equation. So F1 is a positive, it is acting upward, and plus 290 sin 36 degree which is acting also upward, it's a positive degree, positive, and the third force, that is F4, is 370 degree, so 370 force sin 70 degree which is acting downward, so it is negative. So this will be equal to 0. Now to again F1 will be equal to 370 sin 70 minus 290 sin 36 degree, you will get the value of F1. So F1 will be equal to 177.23 Newton. Again it's a positive, it will acting like this. So I hope you understood this problem. So on this problem, on this kind of conditions, we're gonna solve some more problem in our next lecture. Thank you guys.